Welcome to Cooking with Laurtoria. I'm Lauren.
And I'm Victoria.
And today we are going to prepare something extremely tasty for Thanksgiving with some educational purpose. We are going to show you how to make
photosynthesis.
Woo! This is a chloroplast of a plant cell. On the top we have the stroma, and on the bottom we have the thylakoid space. The subsection of this is the thylakoid membrane. Sitting on the left of the thylakoid membrane is the accessory protein with a chlorophyll on the top with many electrons. In the middle, we have the cytochrome, and to the right of it, we have ATP synthase. The bottom and the top are both aqueous solutions with many water molecules, and here we have an example of a water molecule with an electron. Take note, a water molecule is broken up of hydrogen and oxygen. Now that you know the basics of the chloroplast molecule, we could start the process of photosynthesis. First, a photon of light hits the chlorophyll molecule at the appropriate wavelength. The appropriate wavelength is generally between the orange-red zone and the blue-violet zone. Once the photon is absorbed by the chlorophyll molecule, the chlorophyll releases one electron, which causes it to go out of orbit. Since the chlorophyll has now been oxidized, the chlorophyll now has to gain an electron somehow.
Chlorophyll sounds like borophyll.
To review, oxidation occurs when a molecule, such as chlorophyll, loses an electron. Now, the accessory protein grabs an electron from a nearby water molecule. That's the water molecule. Now there is an unstable H2O, and the cell undergoes photolysis. Photolysis happens when a water molecule loses an electron. It becomes unstable and is freed of oxygen and now has lost the hydrogen ion. Hey viewers, do you remember the lost electron from before? It now gets passed along to the cytochrome. The cytochrome pumps the protons from the stroma across the thylakoid membrane. The cytochrome pumps protons from the stroma across to the thylakoid membrane. The cytochrome, which is excited, is participating in active transport because it requires energy. As you could see, there is a massive amount of protons that have built up into the thylakoid space. This forms something called the chemiosmotic gradient. The chemiosmotic gradient features more protons in the thylakoid space than the stroma.
Take note that there is a constant supply of protons from photolysis and excited cytochromes.
There is a constant supply of water molecules because of the thylakoid space is aqueous.
There is a constant flow of oxygen out.
And there's a steady, ongoing activity going on in the chloroplast at all times. The thylakoid space has reached the ideal pH of 5, and the ATP synthase opens up a little tube. It is more acidic than the stroma, which has a pH of 7. ATP synthase is now activated. A tube is created that sends the protons from the thylakoid space to the stroma. The protons carry energy, and it is passive transport because it goes from high concentration to low concentration. The energy now phosphorylates ADP to ATP, and this is an endergonic reaction. I repeat, an endergonic reaction. Late energy has now been converted into chemical energy, and we have undergone
photosynthesis!
Yay!
Tune in next time where we'll create another edible science project.